welcome all of you to our beautiful session, closing session today actually, on the shitposting AI, an ironic solution to Fruitless online debate. It's such a great honor that all of you are here because I heard there's going to be beer at 5 and you are instead spending your time in here, so thank you for coming. Today we are going to tell you all about how you can train your own shitposting in AI and whether you should do this. And before we do that though, we quickly want to introduce ourselves because with me here on the stage is today Thomas.
Yeah, my name is Thomas Endres. Probably most of you have already heard us at the keynote. So I've been with TNG, Technology Consulting, the company we're representing here for 14 years now. I'm one of the managing partners. And together with Martin, 10 years ago, I founded the innovation hacking team.
Yes, right, the innovation hacking team. Yeah, probably that's enough to say because we already had a keynote talk. So Jonas?
Okay, yeah, my name is Jonas. I'm a senior consultant at TNG. Who's been to the keynote actually? Okay, yeah, almost everyone. Okay, talk's over because we've already talked about everything. No, I'm kidding, of course. So I talked about the innovation hacking team. Actually, Thomas did. So what is the innovation hacking team? Well, that is a team within TNG that doesn't work for a customer, but instead creates prototypes that showcase innovative technologies. And we go out there and show them to the world as we're doing today. And so over the years, we've worked on a couple of different projects. You've probably seen them already. So for example, we had real-time deepfakes. So those are deepfakes that run in real time. So the basic process here is we go over a video or a live stream and we replace every single face with a much nicer one. So this is very cool, and you might now ask yourself, why would TNG support this? Why do we do innovation hacking? Well, there's a couple of reasons for that. So first reason is because it's a lot of fun. And not just for us or the people who get to play with the deepfakes, but also for everyone who's involved in these projects. And that is important because these projects are not only done by us three, but a whole team of regular daytime consultants who use this as a learning experience. Because remember, we're working on cutting edge technologies that are maybe not that requested by customers yet, but they might be in the future. So that's why we use these projects to kind of learn skills before we need them. And the third reason is because we want to go out there and we want to let you know that we know all of these things. So we, for example, go on to conferences as we're doing today, or we have a situation like this, Thomas sitting in front of a camera giving an interview about real-time deepfakes, or something like this, Thomas in front of a TV camera giving an interview about real-time deepfakes, or this occurrence right here, very, very rare, Thomas in front of a camera or German television giving a deepfake interview. So you can see we get around a lot and we talk a lot about our stuff. And the pesky side effect of that is that every single time we do this, we have to bear the consequences. We get a constant stream of comments about our projects. Here you can see a stream of comments on the German tech website, which is called heise.de. We'll just pick one out and have a closer look at it. So this one is in German. We translated that for you. And it reads like this: the employees of TNG Consulting. That's not what our company is called, by the way. Cover the cam with tape on their notebooks. How do I know? Because everyone does that. I still think we did the Amish people wrong. Now, who in the audience can tell me what this has to do with deepfakes? Well, I thought so. We don't know either, and for that reason, this classifies as a shitpost for us. And however, our typical reaction is we kind of have to get our opinion out there as well. We have to respond. And over the years, we realized, well, we're spending more and more time arguing with random people online than we are actually doing cool stuff. And we felt like that we were kind of stuck in a cycle. And that cycle is what we call the shitposting circle jerk. So let's have a closer look. On the right side, you can see the average internet user writing a mean comment about one of our showcases. And then on the left, you can see the average TNG consultant who then has to do the job of replying to this. And that's not where the cycle ends, obviously, because you've been on the internet, nobody ever changes their opinion. This is just going to go on and on forever. So the shitposter is going to reply, we're going to reply, and it never ends. And we thought, well, this is kind of inefficient. We are fans, we are IT people, we're fans of automation, so let's automate this. So what if we put a bot in our stead, and now we can do fun stuff like work again, and the bot will just reply to the shitposter, and everything is great, right? Well, it turns out, no, this is a way bigger problem. This is like a global problem. Like, on the other side, there is a shitposter who is also wasting his time. So we kind of have to take the human completely out of the loop to make this work. So we came up with this, and you've seen this before if you've been in the keynote. We have this floating natural language processing brain here that will write a shitpost and then also reply to itself, and then reply to itself and reply to itself, and do so in all of eternity. And that leaves us free to do the fun work stuff, and even the shitposter can do some fun stuff with their time now. And you might now be sitting in your seat and thinking, well, this is ridiculous. This will never work because it's a floating NLP brain. How am I supposed to identify with that? And you would be right. We have kind of an uncanny valley here, and we have to bridge that uncanny valley. We have to rehumanize everything again, and we want to do this with robot heads, because what better way to look at a robot head like this and think, hey, this is a human representation of myself I don't have to discuss online anymore. So that's what we want to talk about today. We have a full agenda. We're going to kick things off with a brief look at what is this NLP, natural language processing thingy that I talked about, and how can you do this with neural networks. And then we're going to go over the 3 major steps that we're going to have a look at here. So the basic idea here is we have our AI brain that should generate comments or replies for us. We send those off to our beautiful robot heads, and they will read them out for us. But speaking of NLP-powered robot discussions, Martin, what is even NLP?
NLP, yeah, this is natural language processing. And yeah, actually, it's the field, the scientific field between linguistics and computer science. And yeah, it's already in our daily life, so you use it when you are using your voice assistant. Or, yeah, of course, if you do some, let's say, summarization of documents and stuff. Or maybe for a sentiment analysis. Yeah, and nowadays, it's in our daily life.
Yeah, exactly.
Just use ChatGPT.
Because a couple of years ago, you needed separate neural networks for all of these different tasks, sentiment analysis, summarizing stuff. Now we have ChatGPT that makes all of this obsolete. Isn't that fun?
Yeah.
But ChatGPT is a neural network, right? How do those work, Martin?
Yeah. So we want to have a look under the hood of GPT, and for this we need a better understanding how deep neural networks work. So this brings us back to school. So here you can see a human neuron, and how does that work? So you probably know back from school, you will have some kind of a stimulus, and if it exceeds a specific threshold, there will be an action potential, the neuron will fire, and if the stimulus is not high enough, it just doesn't fire. So in other words, it's like a cut-off function, so 1 or 0. And there was a brilliant mathematician, I would say, who pressed that in a model. And it looks like this. This is an artificial neuron, and the interesting thing is you have your input information, which is a number in this case, x0, and it gets a weight attached, omega 0. So you multiply the weight with this input value, and within the neuron you can add a so-called bias. Yeah? And after that, we have an activation function, and this will calculate the final value, which gets forwarded to the next neuron. We put all our money into this beautiful animation because, of course, you have more than one input. So you can see we have 3 different inputs, and if omega is bigger, greater than 1, the value of the input value gets a bit gets higher, is more important, so to say, and vice versa. Yeah. So now the question is, how do we put text into numbers? Let's have a look. Here we have a text. An example: Jonas Meyer is so nice.
Cannot relate to this sentence.
I can.
You can?
Yeah.
So, what do we do right now?
Yeah, so we do a process that is called tokenization. So we have the string, we want to turn it into numbers, right? So what we do is we split up our string into so-called tokens. These can be words or subwords. In our case, we split it up into 6 tokens. So Jonas and Mayer and is and so and nice become individual tokens here. And the next thing that we can do is we can assign each of these tokens a number. So our sequence becomes 421337, and in this case you will see we have 2 3s in there because we assign every single so the same ID 3. And we can do this real quick here in one of our live demos that I think you didn't see that in the keynote.
No, that was not in the keynote because it was a very boring demo.
Actually, man, you're such a hater. So, okay.
You are framing.
Yeah, exactly. So here we have the beautiful byte pair tokenizer that you might know from small networks like ChatGPT. And what we can do here is we can live tokenize, for example, start typing. And you can see it will tokenize that into the two words start and typing. Yeah, sure, go ahead, type something else.
What you can see here is not every word is a single token, so typing in this case is not a single token, but it gets split into two tokens because, there are long words out there and you cannot assign a number to each and every possible word that is out there, like the German word Donaudampfschifffahrtskapitänsmütze or something like that.
We'll actually have a look at that later, but have a look at this one. Again, welcome is one token, and then TEQnation apparently is something that doesn't occur too often in the English language, so we split that up into 3 tokens. TE for some reason, that stands for Thomas Endres if you're not aware, and then Q and nation as well. But the fun thing is we can now do the same sentence in German. Let's try that.
Okay.
And the interesting part is your tokenizer is always kind of optimized for the dataset that you used. Here they used an English dataset. So if you put in something German, and unfortunately we don't speak Dutch, then that will work a lot worse. As you can see here, herzlich willkommen zur TEQnation Konferenz. You can see that will be absolutely obliterated by the tokenizer simply because it doesn't know the word herzlich or willkommen, and it will split that up into smaller subtokens. So, enough with the most boring demo of the day. Let's move on to this thing here. Who wants to do this?
I can do it.
Okay.
So what we now do is we take the different tokens that we get and we can now put them into a neural network. So normally we have a fixed context size or a fixed length of the input, and if the sentence is not long enough, we can then pad everything out. So this is a special token that we will just use for there is nothing to see here, actually. And then we can put this in our neural network. Our neural network is normally a layered network, so basically, in this case, it is fully connected neural network. So each neuron of each layer is connected with each neuron of the layer before that, and also with each neuron of the layer after that. And finally, we will get some output tokens. So for example, we could now do fun stuff like just recognizing if this is spam or something like that. So
yeah, and you will see here the network gives us a relatively high value of 0.99, so that's 99% sure that it's spam. We know for sure, of course, that this is not spam. So the real value, the ground truth value should be 0. And what we can do here is we can kind of calculate the difference, calculate a so-called loss function from this, and optimize our neural network to kind of classify this better next time. Pretty easy, right, Thomas?
Yeah, not really.
Yeah.
So this is not everything that is in there. Of course, we made some simplifications here just to keep it simple for you, because there are lots of other things like embeddings that we should talk about if we go more into detail, or also the network architecture, but let's not talk about that right now.
Because we only have 45 minutes,
yeah.
So let's jump straight into creating social media comments. For all of you, that is the part where we have the floating NLP brain generating comments. And what are we using for this brain?
Yeah, of course. Some of you might have heard of this small little startup. They just started up. It's called OpenAI.
But they rebranded to Closed AI, right?
Yeah, at some point they rebranded. But nevertheless, so OpenAI, just a few years ago, actually it is really just a few years ago, that they released a small large language model. Back then it was still a small large language model called GPT. So GPT stands for Generative Pre-trained Transformer. But what we had in mind when we really thought about this is the advertising text that OpenAI published on its blog. And they said, we can also imagine the application of these models for malicious purposes, including the following. Automate the production of abusive or faked content to post on social media.
Perfect.
Automate the production of spam content. And we thought, hey, this is the perfect network for us, so let's use that. And then we thought, hey, what does generative pre-trained transformer, why is it called like that? So generative basically means it's generating content, it's not classifying or something like that. Pre-trained means it comes with a bunch of knowledge, so it was trained on a lot of things, including most of the internet actually, so it must always be right.
Sure.
And Transformer is the architecture we are gonna use here.
Yep.
And we can now have a look at a demo, which is, kind of not what you would expect here, because we are using GPT-2 in this demo, and not GPT-4 or something like that you might be used to. So what we can do with GPT-2 is basically a text completion. So
let's wait.
It will also load for some time, because actually this is all done locally. So it runs on this MacBook.
Yeah.
And now we can just
do
start a sentence.
Do what GPT does best. We can just start a sentence, and that is hello. I don't know, TEQnation. Let's just create an output from here. So we give it a couple of words, and what it will do is fill out our sentence. And from that you can see, okay, it has no idea what it's talking about. It's absolutely not knowing what TEQnation is or what language we're even speaking.
Kidney cabbage tune-up, that is really interesting. Let's try it to not overwhelm the network.
TEQnation, how are you doing, is now the input sentence.
Thank you very much for taking the time to answer these questions. So you can see it's very generic, kind of. It just comes up with something that seems legit in this case. We don't have any ability here to really generate a shitpost, because if I just say generate a shitpost, that will not work. And so what we still have to do here, it already knows language, but we still have to kind of train it in order to make it our shitposting AI here.
Yeah, and actually what you can see here is that it's also just completing text. So let's have a look at how it works inside our.
Yeah.
So what you So how this generation is done is basically by putting something like the first words of a sentence into your input. Yeah, we pad everything else out, and then we let that run through GPT. So, and basically what we get is a so-called next word prediction. So we get the most probable next word. So if we type in Jonas, then the probable next word might be Maya. And then GPT is done for now, so we have to put the output that we get into our input again, and we run that through GPT again and get the next most likely word, which is in this case is. And then we go on and on and on and on until
That's not right.
GPT thinks that it's finished. So then we get an end of text token. So Jonas Meyer is a dog. This is a perfect sentence. And GPT thinks there's nothing to add to that. So we can finish that. And this is also how GPT works. So if you have tried it yourself, which you probably have, you see that it's filling out the sentence token by token, and it will at some point then stop. So,
all right.
Jonas, how does this thing work internally?
Yeah, now we can have a look under the hood of this black box GPT that is just being root for now, what exactly it does and what makes it so powerful. So we talked about the transformer architecture earlier. Here we have the transformer architecture split up for you. You can see it consists of multiple so-called decoder layers, and those in turn again consist of a masked self-attention block and then a feed-forward neural network. And the masked self-attention is really the secret sauce that makes transformers like GPT, like all the other LLMs that we're seeing right now, just so powerful at understanding and generating text for us. And we're going to have a look at why exactly that is. But for that, we have to understand attention. And attention you can think of kind of the same way as cheating works in school. So imagine this situation, you're in the middle of a surprise test that obviously you didn't study for. So your objective is in front of you, but you don't have the information required to fill it out. So what do? You have a little look to the right, you have a little look to the left, you identify the information that is most relevant to you, and then you take that information and bundle that on your piece of paper and you're done. And that's pretty much exactly how masked self-attention works as well. So here the objective is to understand what this token he means. Well, in order to do so, we kind of have to have a look at the context that it was set in. And here we can see, okay, he refers to the shitposters mad full stop, right? And what the attention now does, it has a look back in the sequence and identifies the words that are most relevant to understanding what he could mean. And in this case, this is going to be shit and poster and mad, and then obviously he's also going to be immensely important. So we take all of that and kind of weight it by how important it is, and we put that in the output instead of he. We now have shit poster mad he. And that's a lot more information than we have, but also it's a bunch of gibberish, and that's basically why we have the feed-forward neural network here, just to figure out what the hell shit poster mad he means. And another thing that you can see here that is actually quite nice is that the mask self-attention, it's called mask self-attention because it only looks backward in the sequence. And that's also the reason why we can generate one token into the future at a time. That's how all of this works. And now the thing is, we've understood how GPT works. Now let's choose a GPT for our shitposting AI. And back in the day when we started, we had 2 different GPTs to choose from, GPT-2 and the bigger brother GPT-3. And now you will know there's GPT-4. All of those, GPT-3 and GPT-4, are pretty much politically correct. You cannot also run them on your laptop if you're so fancy. You cannot train them on your own data set, so that is kind of lame. So in the end, we went for GPT-2 because we could run that on MacBooks and we could train it ourselves, and that is pretty good. Speaking of training, Martin.
Yeah, speaking of training.
How does that work?
Yeah, let's have a look. So let's imagine we have the following input sentence, your deepfakes are shit, which obviously is a troll post. And if you put that into GPT-2, for example, then a possible prediction could be for the input this token, the prediction would be mom.
Obviously.
Obviously. For deep, it could be fakes, and so on and so on. And now you would have a result, something like, your mom fakes are nice, and so on and so on. Yeah. The thing, what we can do right now is, we have the ground truth, and this would be your deepfakes are shit, so the original input and the ground truth, and now we make a comparison. So what we actually can see, there is a difference between mom and deep, between nice and shit, and so on and so on.
And that way we can basically train the GPT to produce data that looks exactly like the shitposting data that we use to train it.
Yeah.
And one cool thing about this is we told you how GPT generates new tokens, 1 token at a time, but we can do training like this in parallel, and that's what makes transformers just so powerful.
Yeah,
but
we need the training data.
Yeah, we need the training data.
We need the data.
And where is the data?
Exactly. Of course, if you happened to be in the keynote, social media is the answer here. And yeah, of course, we took Twitter and Reddit because they are the most elaborate source of shitposts on the planet, I would say. But at the same time, back in the days, they still offered us an API. And an API was very important because we need to scrape this data. We need to get to this data. And for this, there were some Python packages. I'm not going to go into details here, but for Reddit, we just can take some subreddits and then list all the comments, and then we get all the comments that are out there.
And speaking about...
Unfortunately, however, if you just take all of the comments, then you will mostly get some discussions about porn, which is not what we wanted to do with our shitposting AI. We wanted to talk about politics. We wanted to talk about the real stuff. So which subreddits did we use, Mark?
Yeah, speaking about subreddits, so we have chosen, we thought the most controversial posts and shitposts were in politics, in change my view, in unpopular opinion, shower thoughts, and political discussion, of course. Yeah. And one of the most controversial threads was subreddits.
Probably a lot of you can relate, of course, good old mechanical keyboards. Always a good source for shitposts. Okay, so that's Reddit for us. Let's have a look at Twitter.
Let's have a look at Twitter. Twitter doesn't have the same problems as Reddit does, so if we just take each and every tweet that we get, we already get a good sample size for shitposts, and they are mostly political, so that's gonna be fine. We just had some limits for that, in that we could just scrape a number of tweets per month and a number of tweets per hour, and so on and so on. So, but this was not a big problem for us because we wanted to have something that was continuously working on the newest news that are out there, on the newest shitposts that people produced. So we were fine with that.
But what is the big problem with social media comments, Thomas?
Yeah, the big problem is that you get something like this out of that. So you have a post, then somebody replied to the post, another one replied to this post as well, and then somebody insulted the mom of the first replier, and of course this one had to reply to that as well, and so on and so on and so on. So you get somehow a tree of comments. And yeah, our training data doesn't work on trees, it just works on a bunch of tokens, right?
Right, yeah.
So,
what do we have to do, Thomas?
Yeah, we have to employ a technique which we call thread flattening. So we basically just take the tree that we get, and then we just do a depth first search into this tree, and we separate everything with end of text or end of comment tokens.
That's right.
And with that we can then we just get a nice list of tokens. Just everything is neat and flat. Unfortunately, of course, we lose some structure if we do it, but to be honest, there was never too much structure in it anyway, so we're fine with that. So now we can train our neural network by just scraping into some data buckets from that we can, and from that we can also train our neural network. But so not to mix and mingle our training with the scraping process, we took 14 different buckets for 14 days, and on the first day we just scrape into our first bucket and we learn from all the other buckets. And if we advance to the next day, we're gonna scrape into the second bucket and learn from all the other ones, and so on and so on and so on. And then we can train our neural network to always have the newest data available that is out there.
And imagine the look of our face of like over-engineering this to perfection, and then like 2 weeks after the first talk that we gave about this technology, then both just shutting down the APIs. That was just fantastic. Yeah. But with that, we now have our beautiful trained GPT. We had actually a cloud sync in there, so it would constantly train and sync to the cloud. Beautiful stuff. And now we have our shitposting AI that we can just see the conversation with.
Which is also a bit frozen in time because, we stopped scraping someday in 2021 or something like that. So we are still stuck with the topics back then. And of course, back then, COVID was a thing. But we can also have something.
Let's take another very controversial sentence. Let's see what
this was also true.
At some point, this was true, yeah. Let's see, now processing. Oh, wow, this is not looking too promising.
There it is.
There we go.
No, it isn't. The problem is that I don't love conservatives and I'm so sick.
And you can see already at this point, already at this point, the shitposting AI doesn't feel like talking about Trump anymore, so it just goes off into some other random direction and talks about...
Do you know Rand Paul?
I do not know, and it just makes up some random stuff, and Republicans, okay, sure. And you can see, you can literally just see any kind of conversation, and will carry on doing, coming up with the worst kinds of arguments. Oh no. And
this is probably...
And you can see, it really just learned the lingo and just the bad takes from the training data, just like we wanted to. Okay, now we're getting...
For scientific reasons,
For scientific reasons, exactly. And now we get some, okay, let's stop it right here. And talk about how we can now fake human voices. So now we have an AI that can generate shitposts for us, but we still need the part where the sound waves come out of the robot head, so we have to turn that text into speech or audio. And if you think about this, this is actually kind of a known problem. So if you have, for example, a smart home assistant at home, or you have a smart assistant on your phone, you will probably know that thing has a text-to-speech engine to talk to you. And at the beginning of this project, we had a look at these smart home assistants, the Google Home Assistants, and at the text-to-speech engine that they're using, which was called TEQnation 2. And sadly, TEQnation 2 doesn't look like this. I was just very hungry creating this slide deck. It looks more like this, actually. So what TEQnation 2 does, it takes a piece of text as input and it turns it into a waveform of the speech. And it does so in 2 big steps, essentially. So the first step is to turn our text into tokens, and then those tokens into what is called a MEL spectrogram. A MEL spectrogram, that is basically a visual representation of different frequencies over time. So it does so with a so-called spectrogram prediction network that again consists of 2 different parts, an encoder and a decoder. The details don't really matter here too much. And then when we have that MEL spectrogram, we can turn that into a waveform with a vocoder. That is basically what a vocoder does. In this case, we're using WaveNet, that is a neural network, because that gives us very natural sounding voices like the ones that you're about to hear right now.
Yeah, so let's have a look to this one.
The meaning of life is not simply to exist.
You can maybe tell that we're fans of Arnold Schwarzenegger for his voice.
The meaning of life is not simply to exist.
Yeah, you can identify somehow the dialect, but the most interesting thing behind that is that a few years ago, so this was the quality.
The meaning of life is not simply to exist.
So nowadays with 11 labs, for example, you get much better outputs within just a short amount of time.
Yeah, but let's have a look at the multi-speaker TEQnation.
Exactly, because who wants to have 2 robot heads that only have the voice of Arnold Schwarzenegger? No, we wanted more voices. We wanted, ideally, millions of voices, so we can give every single argument a unique voice. And this is where the multi-speaker TEQnation comes in, because we don't want to train a lot of TEQnations on here. We simply do an extension to the existing TEQnation. What this now does is it accepts a second input, a so-called voice sample, so that's a sample of the voice, and that will get broken down by a so-called speaker encoder into what is called a latent space representation. That's basically a vector that stores the properties of the voice. And we can feed that into the decoder part of the spectrogram prediction network, and that will lead to us getting a final voice sample or voice output that sounds like the sample that we put in initially. And we thought, whoa, what a great idea this is. Let's just take the TEQnation implementation and just add in this speaker encoder thing and train it ourselves and then see what we can get out. And we built this ourselves and we trained it and got this thing out.
Control of the Senate. I never really understand why Republicans ever want to support anything the other side says they do. It wasn't really a Twitter update until I was in for the ride back from.
It's a nice dubstep, right?
Kind of. Yeah. Another way to look at it is, Thomas already said, we don't want to be talking about porn all the time. So at this point, we decided to just give up and use something ready-made. Because there's Cocky AI, they have a solution called Glow TTS. It's open source, you can download it as a Python package. And it comes with a bunch of different voices, and at that point, we'd spent like 2 months on multi-speaker TEQnation and said, okay, sure, let's just use this. If you have connection to the internet, then you can use, of course, also cloud services like Amazon Poly. That's what we're using if we have internet access. And as Martin mentioned before, you can now also use 11 labs to clone voices. About Poly, the neat thing here is we have a bunch of different voices for all kinds of people. So, for example, we have this one.
Hi, my name is Joanna.
And then, of course, if you wanted to shitpost on French, in French, then well, you know, you can do that if you want.
Salut, je m'appelle Léa.
So that basically solves the task of turning our text into voice. And now let's go about building robot heads, right? So that's the part where we have robot heads.
Yeah, robot heads, yeah. Let's have a look. So this is more of a slideshow right now. Yeah, okay, we are really experienced with robotics, yeah, you can see with the Now robot here.
You can see this video was taken a long time ago.
Yes, actually.
This is Martin, by the way.
It was before 2017, I expect. Okay, so let's have a look to the hardware setup. So here, these are our robot heads. So actually this glass housing, and yeah, inside we have a Raspberry Pi, Arduino. So to the Raspberry Pi, we use that for the Wi-Fi connection. Loudspeaker is attached, and the Arduino.
Yeah, exactly, because just like every normal human being, this thing has to have like a circling light on the forehead when they think, and also some very uncanny bridging red glowing eyes. So just to make you feel that more comfortable.
Yeah, so this is the chassis, and then we have this stuff here. So on the base we have the loudspeaker, and
Martin doesn't know.
Yeah, that's actually how it looks like. So it's nothing spectacular here in this case.
Come on, we
compared to the expectation at least.
Yeah, okay,
to say so.
We expected kind of to get something like this. Out came, well, you know, this thing here.
And
so.
it is close enough, I would say.
Speaking about glass heads, what could possibly go wrong?
Yeah, sure. It's who would have thought that bringing glass heads all the way from Germany to the Netherlands
this happened in
an airplane? Yeah, sure. But who would have thought that this might be a bad idea? So if you want to see a nice robot head, there's this guy in the front row. He will gladly show you his.
At his booth.
Yeah, sure. Or not really. Whatever. Right. Let's talk about putting everything together, because we've seen the floating robot head, we've seen how we can generate audio from here, and we've also seen the robot heads. So now let's have a look at how we can put all of this together.
Unfortunately, AI takes a lot of computing power. Also, back in the days when we are still using things like GPT-2, they normally use things like GPUs, and we thought, hey, let's have everything in our data center so that we can really, so this is our data center.
Actually, to be fair, this used to be our data center. We now removed the fans. It's way tighter now. Yeah?
And with that, we can then steer our robot heads, because we cannot really put everything on the robot's heads. And that's why we need kind of a server-client architecture. So the server is basically there for creating the shitpost with GPT. It's there for creating the speech or the waveforms of the speech using the TTS software that we use, using Cocky TTS. And then on the other side, we have our clients, and they are connected using TCP sockets. And we can now just, at the beginning, when we start thinking, we can then tell the first head here that it should start thinking. So the circular lights go on, and then we also start thinking. So we create our shitpost, we create the speech, and once it's done, we can tell it to stop thinking and just to read it out aloud. And once it's done, it will then send, I'm finished with reading that out, and we will jump to the next head and do the same all over again.
Yeah, cool. And who has paid close attention, and anyone who knows server-client architectures know that for some reason our server is a client and all the clients are servers, technically speaking. All right, and so of course also one thing that had to be done, we had to build like a neat front end so all of you in the audience who cannot hear the heads can at least read something. And our front end looks a little bit like this. So you can see we took inspiration from the shitposter's favorite, from the shitposter's favorite social media platform or messaging platform. And this means now we have all the components together to finally show you how it works. So we're going to power these up. They are going to start booting, indicated by the waiting light here. And once they're done, they're going to connect to this laptop where the shitposting server is running right now. And then at some point, they are just going to start talking and hopefully not continuing whatever this is. Oh, no,
it's just...
The best thing is when you build like electronics like this yourself and you have speakers involved, and like exposed wires, you will just get very much coil whine.
I'm so sorry for your loss, but this is life-saving.
I think it's this one, right?
I'm sorry, but not enough for my Shonique playlist.
The speaker's down here.
I hope he's doing a TEQnation conviction. Years support Demasha Skolta Lavos and Double Fight for Sanu Goibad Day. Förtsch was this.
Don't have to do this.
Request Friday Live Stream Fly and Skate Emission Spotify Shakju. So Hey John Ho Hey John is an American singer, composer, and rapper.
And here you can see why it's a good idea to filter your data
Support
in
Damasha
case
Skolta.
there is spam bots going around while you're scraping from Twitter and Reddit. Yeah. So for now
Request
and forever.
Friday Live Stream Fly in the Sky Fight Form. Send Tom Kayla request.
Yeah, okay.
Yeah, we've kind of found out over the last years. I'm just gonna. Or no, we're just gonna leave it.
We're just gonna leave that running.
So one thing that we noticed over the last couple of years is like this last version of the model that we trained while we still could scrape data, it kind of ran into spam bots, and now it will sometimes get into these loops where it will never come out of, and it will always just show Dimash Askolta and his beautiful music. He's a Vietnamese artist, apparently. We don't know about
actually, what didn't work in our keynote, there is a URL.
Yeah, we
t.co blah 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 blah.
Yeah, it made up some fake Twitter URLs. Anyways, let's stop this for now.
Really stuck in a loop, right?
There we go. Perfect. So now you just saw, we did it. We did it. We basically solved the biggest problem of the 21st century, which is online discussion. So you don't have to do it anymore. Well, at least that's what we thought we would have achieved. But turns out not every one of you can have these glass heads at home and like a laptop that runs like 3 different Python processes to do this. So we thought, well, maybe we should publish this. Maybe everyone should have a right to shitposting because we already have a web front end. We can just put this on AWS and then all of you can just have a tab open with this stuff going on and then you can actually do some work. And turns out we built a little AWS deployment pipeline for all of this. We had all of this running. We just had to push the little red button to deploy everything. And then we thought, might be a good idea to talk to one of our lawyers first. Well, you can't imagine what he said. Turns out even before the AI Act, this would have been a terrible idea because no matter whether you're on the safe side, like from a law standpoint, it can always be a bad look if you have like some website where there's some horrible stuff going on. And we don't even have to think about this because somebody has done this before. Thanks to Microsoft, because what they did back in the day is they put this bot online, this TEQnation bot that learned from other tweets how humans interact. Turns out it got racist very quickly and also like bigoted and everything. And this tweet that we selected out here is actually one of the best ones that it produced, like the least controversial one. So no shit posting for you, sad. We want to give you something else though. So you remember the bigger brother GPT-4? We actually built something kind of more useful with this, which is AI slides. So here you can see the absolutely real Thomas telling you all about how great our beautiful website aislides.com is. And so what you can do here is you can just type in your title of your presentation, and what AI Slides will do is generate a complete presentation for you. For example, how to spot a deepfake. That is random. So it even takes care of the presentation itself. So if you want to check this out, just scan this QR code over here, go to aislides.com. It's completely free to watch our AI-generated slides. Yeah, so do that. And with that out of the way, that's all that we have for you today, and we are perfectly on time.
It's awesome.
We have 1 minute for questions. Isn't that great?
Yeah.
All right.
Or we can just grab a beer outside and have a discussion on that.
Yep.
Sure. Thanks for having us.
Thank you.